Okay, so today we're going over 9.1 right triangle trigonometry. Part of this is information that you had in geometry. So in geometry, you learned about Sohcahtoa. And Sohcahtoa is right triangle trig, and it is just a way to remember the formulas for sine, cosine, and tangent. So on the S stands for sine, and it's the sine of the angle. I'm going to put capital A for angle, equals the opposite side over the hypotenuse. Ca stands for the cosine of the angle, equals the AH is the adjacent over hypotenuse. And toa tells you that the tangent of the angle equals opposite over adjacent. So when we talk about Sohcahtoa, that's just a mnemonic device to remember. The so tells you sine is opposite over hypotenuse. Cosine, the ca tells you cosine is AH, adjacent over hypotenuse, and tangent is OA, toa, which is opposite over adjacent. Okay, so these are the 30, 60, 90, and 45, 45, 90. These are special right triangles from geometry. So they want us to go ahead and find the exact values, not decimals, of sine, cosine, and tangent. So the sine of 30 degrees is the opposite side of 30. So from 30, 1 is opposite. And this is the hypotenuse. So it is opposite over hypotenuse, which is 1/2. And that's the exact value of the sine of 30 degrees. The cosine of 30 degrees is the adjacent side over the hypotenuse. So the adjacent side is the square root of 3, and the hypotenuse is over 2. And then the tangent of 30 degrees is opposite over adjacent, which is 1 over square root 3. And then you need to rationalize the denominator because you can't leave that radical on the bottom, and so you end up with square root of 3 over 3. Okay, so for doing 60 degrees, what changes, the hypotenuse is still the hypotenuse. That does not change. But what changes is now when you're looking from 60 degrees, the square root of 3 is the opposite side, and the 1 is the adjacent. So now the sine of 60, opposite over hypotenuse, is square root of 3 over 2. Cosine of 60 is adjacent over hypotenuse, which is 1/2. And tangent of 60 degrees is opposite over adjacent, which is square root of 3 over 1, which becomes just square root of 3. Now, note there's some special properties about this. So it is not a coincidence that the cosine of 30 and the sine of 60 are the same. They are equal to each other. And the sine of 30 and the cosine of 60 are the same. They are equal to each other. So the reason that this is it's how the perspective changes. And that means that how to summarize that in a rule is that 30 degrees and 60 degrees are complementary. So the sine of an angle is the same as the cosine of its complement. The cosine of an angle is the same as the sine of its complement. And remember, complementary angles are angles that add up to 90. And the reason this works is because in a right triangle, you have a 90-degree angle. The two acute angles are complementary. They add up to 90 degrees. Now, the tangent of an angle, it was 1 over the square root of 3 before I rationalized it. And then its complement was square root of 3 over 1. So the tangent of one angle is the reciprocal of the tangent of its complement. Okay, now let's look at the ones that are 45 degrees. So on that one, we're going to have the sine of 45 degrees. So pick either 45-degree angle. I'm going to use this one. And so this is opposite over hypotenuse. So 1 over the square root of 2. We're going to rationalize the denominator, and we get the square root of 2 over 2. Cosine of 45 degrees is going to be the same thing because the adjacent side is also 1. And so when we rationalize the denominator, we get the square root of 2 over 2. And then tangent of 45 degrees is opposite, which is 1 over adjacent, which is 1. So the tangent of 45 degrees is 1. Okay, so now just going over where we have right here the definitions of sine, cosine, and tangent. So as we know, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we also have the 3 other trigonometric functions that are actually reciprocals. So honestly, I don't remember this specific line. I prefer to remember this row right here. So I know that cosecant, it's abbreviated CSC. So when you see CSC, how you say that out loud is cosecant. And it is the reciprocal of sine, so it's 1 over sine. Secant, so SEC, how you say that out loud is secant. And it is the reciprocal of cosine, so it's 1 over cosine. And then cotangent, COT, how you say it out loud is you say cotangent. And cotangent is the reciprocal of tangent. Now, I will also add on that another thing I'd like you to know is that tangent of theta, theta is just some angle, is the sine of theta over the cosine of theta. And then also cotangent, if it's the reciprocal of tangent, then it's cosine of theta over sine of theta. So let's add those on. So I remember this bottom part, and one thing, just kind of a trick how I remember it, might be kind of silly, is I think of it as, okay, cosecant goes with sine, you have to have a C with an S. You can't have, like, people get mixed up and want to do secant with sine, but it's cosecant with sine and secant with cosine, so an S with a C. So they're not the same initial letter. And then I think cotangent and tangent is pretty obvious. Okay, so this wants us to evaluate the 6 trigonometric functions of theta. So theta is our angle right here. So 12 is the opposite side, 5 is the adjacent side. And to find this missing side, this is the hypotenuse. And we could plug this into the Pythagorean Theorem, which is 5 squared, right? Leg squared plus leg squared equals hypotenuse squared. So 5 squared plus 12 squared. And then when you square root it, it is 13. It's also Pythagorean triple, so we may just know that one in our head. Okay, so the sine of theta is opposite over hypotenuse. That's 12 over 13. So that means that the cosecant of theta is 1 over sine, which means it's the reciprocal, it's 13 over 12, or hypotenuse over opposite. So cosine of theta is adjacent over hypotenuse, that's 5 over 13. So secant is the reciprocal of cosine, so that means it's 13 over 5, or hypotenuse over adjacent. And then tangent of theta is opposite over adjacent, so 12 over 5. So then cotangent of theta is the reciprocal, it's 1 over tangent. So it's the reciprocal identity, so it's 5 over 12. Or instead of opposite over adjacent, it's adjacent over opposite. All right, looking at this one, this is the same type of problem, except they are going to give us sine, and so we need to make our own triangle. My advice is draw a right triangle. Don't worry about getting it to scale. Just do the best you can do. This is theta. If sine is 4 over 7, then that means the opposite over the hypotenuse is 4 over 7. Now, that does not mean that the side lengths are 4 and 7. It means they are in the ratio of 4 to 7. So for example, the side lengths could be 20 over 35, like the hypotenuse is 35 and the opposite side is 20. Those are in the ratio of 4 over 7. They could be 8 over 14. Those are in that ratio. So we are using the ratio to find the other sides, but remember that's the ratio, not the actual length of the sides. So to find the missing side, I'm going to use the Pythagorean Theorem, and basically it ends up being square root of 33. All right, so sine of theta is 4 over 7, and that means cosecant of theta is the reciprocal of that. It's 7 over 4. So cosine theta is adjacent over hypotenuse, so that means it is square root of 33 over the hypotenuse is 7. So that means secant theta is the reciprocal of this, but then you have to rationalize the denominator. So times by the square root of 33, we've learned this previously. So we get 7 square root 33 over 33. And then tangent of theta is opposite over adjacent, so 4 over square root 33, which that rationalizes to 4 square root 33 over 33. You have to rationalize the denominator. And then cotangent of theta is the reciprocal of that, which is the square root of 33, or the adjacent side, over the opposite side. Okay, this chart just summarizes what we did at the very beginning of our notes, where we found the sine, cosine, and tangent of the basic all the trig functions for the special right triangles. So these topics, these are amounts we're going to know. So honestly, I more or less have kind of these memorized, the basic sine, cosine, and tangent, or at the very minimum, I can draw a picture of the triangle and find them if I need to. All right, example 3a wants us to solve. When you solve a triangle, you're finding every missing piece. So angle A is 28 degrees. We don't know angle B, and angle C is 90. So to find angle B, they should add up to 90, the two acute angles, A and B. So we can do 90 minus 28, and we are going to have that be 62 degrees. Now the sides, same thing. We are going to find how much they are. So B is 15. Now, when you're finding the other sides, make sure to use the side you already know. So I want to continue to use, like if I'm finding A, I want to use side B. I don't want to use a number I have that I've rounded from a previous part of the problem, because that rounding can increase and ultimately cause us to be just off enough that we're wrong. So from 28, A is opposite and B is adjacent. So that tells me we have the tangent of 28 equals A over side B is 15. So to solve for A, we multiply times 15. And we type that in our calculator. Make sure you are in degree mode because this angle is in degrees. And I get 7.98. So then for side C, what I'm saying there is don't use side A to find it. Go ahead and use side B that you already knew and side C. So that's adjacent and hypotenuse. So that tells me we should use cosine of 28 equals the adjacent over the hypotenuse. Now, when the variable's on the bottom, we're going to go ahead and we're going to multiply times C on both sides. What that's going to do is that's going to keep it out of the bottom of the fraction. So then we have C times cosine of 28 equals 15. Let's divide by the cosine of 28. So that's what we put into our calculator is 15 divided by cosine of 28, which I get C equals 16.99. So basically 17. They didn't say what to round to though. Okay, this is another solving one, but you see here, they're telling us, and this is not to scale. We use these pictures over and over, honestly. So this is telling us A is 71 degrees. So that's 71 degrees. I don't know B. And C is 90 degrees. So to find B, I can just do 90 minus 71. So I'm going to get 19 degrees. Okay, so now on the sides, I know that C is 20. I don't know A and B. So I don't know A, I don't know B, and I know that C is 20. So if I want to find A is the opposite side of 71, and C is the hypotenuse. So that tells me I'm going to use sine. So I'm going to do the sine of 71 degrees equals A over 20. So we multiply by 20 on both sides, and that is what we type in our calculator, 20 times sine 71, and I get 18.91. And then to find B, that is the adjacent, and C, the 20 that we know, is the hypotenuse, so that's cosine is B over 20, and then times by 20, and so we're going to do 20 times the cosine of 71. Which is 6.51. Moving on to example 4, it describes that we were at point A and measured a 90-degree angle between B and C. Then we walked 2 miles to point B and measured a 76-degree angle. So as you can see in the picture, basically what we end up with here, sorry about that, is a triangle that is angle A is the right angle. This is 2 miles. B is 76 degrees, and they're asking us how wide is it from A to C. So that's this distance right here. So I'm going to call it X. You could also call it side B. So I have opposite from 76 and adjacent. So that tells me to do tangent of 76 equals opposite, which is X, over adjacent, which is 2. So then I'll multiply by 2, and I'm going to get 2 times tangent 76. And so X equals about 8 miles. Okay, for time on the video, I went ahead and drew this out. So you have a boat, here's the rope, and here's your parasail. The rope is 72 feet long. The angle of elevation is 28 degrees, and you want to know how high the parasail is above the water where the boat is. It just means how high above the water they are. So because this is opposite and this is hypotenuse, I went ahead and set up a formula and found 33.8 feet. And here's a few notes about depression and elevation.